Okay, let's dive right into this explainer. Today we're looking at what is absolutely one of the most violent, dramatic, and awe-inspiring events in the entire universe. We're talking about the final act of a cosmic dance. It's a cataclysmic upheaval of space-time itself, where matter and energy get transformed in ways that are, honestly, almost impossible for the human mind to fully wrap around.
But to ground this incredibly massive concept, let's start with a surprisingly everyday question. Where did the gold on your finger actually come from? Seriously, to understand the true origins of the jewelry you might be wearing right now, we have to investigate a massive cosmic cataclysm. It's not just a rock dug out of the Earth. It's literally a physical piece of deep space history.
Section 1. The Ultimate Cosmic Dance. To see exactly how that precious metal was made, we need to go back, way back.
Our thriller begins quietly in the dark expanse of a binary star system. Picture this. We have two incredibly massive stars orbiting each other. Over an immense span of time, these stars reach the end of their life cycles. One goes out in a massive supernova and collapses into a dense neutron star, while its partner takes an even more extreme path, collapsing completely to become a black hole. They both survive their respective deaths, but they're locked together, spiraling inward and drawing ever closer with every single rotation.
Section 2. Meet the Cosmic Titans. Before these two giants inevitably collide, let's properly introduce the heavyweights in this cosmic boxing match.
The mind-bending contrast between these two objects is just wild. On one side, you have the neutron star. This is the remnant of a star, roughly the mass of our sun, but compressed into a tiny sphere only about 20 kilometers across. Its internal structure is just tightly packed neutrons, and it features a crust that is actually harder than steel, spinning with a magnetic field billions of times stronger than our sun's. And then, on the other side, the black hole is this completely surfaceless, mysterious entity. Beyond its event horizon, space-time collapses entirely, and not even light can escape its gravitational pull.
To really grasp the physical extremity of that neutron star, just consider this number: 1 billion tons. If you were to somehow scoop up a single ordinary teaspoon of material from a neutron star and bring it back to Earth, it would weigh 1 billion tons. That is the unbelievable density we're dealing with as these two objects hurtle toward one another.
Section 3. Ripples in the fabric. As these incredibly dense titans orbit each other, they don't just move quietly through space. Their immense mass actually warps the very fabric of space-time itself. Einstein's theory of general relativity predicted this perfectly. They warp space-time, radiating energy outward in the form of gravitational waves. And with every burst of energy they release, their orbit shrinks and the spiral gets tighter. This dance takes millions of years, but beautifully, following this exact trajectory brings us to the very first direct human detections of these specific mergers. In 2020, the LIGO and Virgo detectors recorded two monumental events, which we designated as GW 200105 and GW 200115.
You know, the precision of our modern technology is just staggering. These gravitational waves travel at the speed of light, carrying the echoes of this collision from billions of light years away. By the time they finally washed over our detectors in 2020, the ripples shifted space by less than a fraction of a single proton's diameter. Yet it was strong enough for us to detect at the absolute limits of human capability. Absolutely incredible.
Section 4. The Violent Climax. So we're leaving that millions of years-long dance behind and entering the split-second conclusion where things accelerate incredibly fast.
As the objects draw perilously close, the black hole's tidal forces completely take over. This is the immense difference in gravitational pull between the near and far sides of the neutron star. If the black hole is relatively small, these tidal forces physically shred the incredibly dense, steel-hard neutron star into ribbons. It's a brutal process known as spaghettification or tidal disruption. The star is literally torn apart by overwhelming power.
Crucially, though, there's actually an alternate ending to this story. If the black hole happens to be very large, the neutron star isn't torn apart into ribbons at all. Instead, it just passes beyond the event horizon and gets swallowed whole in a single silent moment. From an outside perspective, there's no grand explosion, no final flash of light, just a quiet, irreversible disappearance into the void.
But let's look at that violent shredding scenario, because the chaos there unfolds in rapid, dramatic steps. First, the star is shredded. Then, the shattered matter spirals outward, forming a massive accretion disk around the black hole that reaches unimaginably high temperatures of trillions of degrees.
From this extreme fiery environment, blinding relativistic jets of particles are launched outward in opposite directions right from the black hole's poles.
These extreme jets create what astronomers call short gamma-ray bursts. They last for only a few seconds. But in that fleeting moment, they release more energy than our entire sun will emit over its complete multi-billion-year lifetime. They are so devastatingly powerful that if a burst like this occurred just a few thousand light-years away from Earth, the intense radiation would threaten all life on our planet.
Section 5. Forging Gold in Darkness. Beyond the pure destruction, there is an astonishing alchemical legacy left behind by this incredible event.
As the neutron star's matter is violently torn apart, it releases an intense flux of neutrons. This triggers a very specific mechanism known as R-process nucleosynthesis. This right here is the exact process by which the universe creates its heaviest elements heavier than iron. This extreme trillion-degree forge is what creates the universe's supply of gold, platinum, uranium, and so many other precious elements.
So the crucial takeaway is this. The gold jewelry on your hand right now, the platinum in your electronics, was literally forged and scattered across the cosmos by one of these exact collisions billions of years ago. Every single gold ring is an enduring physical relic of incredible cosmic violence. How cool is that?
Section 6. A legacy in silence. So, what happens after the explosion?
Well, once the blinding gamma rays fade and the violent collision finally ends, the universe returns to an eerie, warped silence. In the aftermath, a newly enlarged black hole remains in the dark, having totally consumed the mass of the neutron star. It's possibly rotating now with an even more intense magnetic field and extreme energy. And drifting away from it, dispersed across light years of empty space, is a massive, glowing cloud of newly forged stardust. Heavy elements that will eventually drift through the void to seed new solar systems and new worlds.
As we wrap up this explainer, I want to leave you with a provocative thought. These incredible events teach us something much deeper than just physics. Every single atom in the universe is part of a story. And if we are all truly made of star stuff, what ancient, silent, and incredibly violent chapters of the cosmos are hiding right now in your very own chemistry? Keep looking up, keep asking questions, and we'll see you next time.